Okay, 10 seconds after its projection from the origin, a particle has position vector of 150i minus 200j. So you can see here I've represented that on the diagram. Yes, projected from the origin, so it goes up and then it falls, and you can see then the 150 across in the horizontal direction, the x direction, which is the I notation, of course. And then the j then represents the y direction. Because it's minus, it's obviously in the negative region of the axis here. So that's the position vector. Okay. In other words, when t is equal to 10, okay, this position vector s is equal to 150i minus 200j. Okay, so we know what s is when t is 10. The other thing we know as well, of course, is acceleration, the vector for acceleration. Now remember, there's no acceleration horizontally, it's just vertically, so that'll be minus 9.8, okay, j in the vertical direction. So if I use s equals ut, as we always do with projectiles, okay, s equals ut plus half at squared, I can sub in what I know, and I can work out then what the initial velocity is, okay, the velocity of projection, yeah, which is u. So t is 10, yeah, minus 9.8 for acceleration, and subbing in 10 then for the time. Okay, don't forget to put your j there for your vector there to show the direction it's going in. So we'll just tidy up here the right hand side. So we've got 10u here, and then when I work that out there, well, we'll have 1/2 times 9.8 times 10 squared, which is 100, so you get 490, and of course because there's a minus there, minus 490j. So if I take that then, minus 490j over the other side, becomes a plus 490j. So I get 10u equals to then, well, if I put these together, 150i and minus 200 plus 490 is 290j. Okay, so that's what 10u is. To get u then, of course, you just divide by 10. So you get 15i plus 29j. Okay, so that is the velocity of projection. Okay. Now it says then, right, find the minimum speed of the particle, and perhaps this really should be a hence part, hence find the minimum speed of projection, because if you remember, minimum speed of the projectile, if you remember, okay, when it comes to the velocity, all right, the horizontal velocity never changes, doesn't it? Okay, so when we go back to the start here, we've got 15i plus 29j, okay, while the horizontal part of that velocity, 15, stays the same, stays constant, because there's no acceleration acting horizontally. The 29, the vertical component of the velocity, does change, doesn't it, because gravity affects it. So to get the minimum of this, okay, minimum of velocity throughout its journey, okay, we've got to realize that the 15 will always be 15. It will not change horizontally. Horizontal velocity is the same. It's the vertical velocity we need to look at to get it at its minimum. Of course, it'll be at its minimum when it's at the top, yeah? So when it's at the top, okay, the vertical velocity will be 0. So remember, we can say, look, at max height, okay, remember Vy is equal to 0, we would say, the velocity in the vertical direction. So i.e. the j component of velocity will equal to 0. Okay, so our velocity then will actually just be 15i plus 0j. Okay, which of course will be 15i. So if it's just 15i, this we can say then the speed, or the speed at its minimum, will equal to 15 meters per second.